In this section for, I think we call it section 3.4, so let's put that on here. There were two worksheets, by the way, for the last section, so make sure that you did two of them. They were, I'll tell you what color they were. I'm going to find them here for a second. Prior to this lesson, you should have done a worksheet that is, just a second here, you should have done a green and a salmon colored. So make sure you did green and salmon before watching this notes. They'll say worksheet number 3 and worksheet number 4. All right, so as usual, put the date on it, and our objective today is going to be to multiply rational expressions, and rational really just means a fraction. So we're going to be multiplying some fractions, which you've been doing since elementary school, but when it's called a rational expression, it really means it's a fraction that has some variables in it, and so we've got some rules we have to follow. But before we begin, let's just do a quick little review of how we multiply just regular old fractions. So let's suppose we had an 18 over, let's just say 7 times a 21 over 6. If you were to multiply straight across and then reduce, the fraction gets really large, 18 times 21, and you'd probably have to take out a calculator. So what we do is we cancel out common factors first. We're really dividing a 6 out of 18 and a 6 out of the bottom. Really, you're thinking of 18 as 6 times 3, and you're canceling a 6 out, leaving a 3 on the top. With the 21, same thing, divide by 7, divide by 7. Now when I go straight across, I get 9 over 1, which is just 9. And that process holds no matter how ugly the fractions get. So what we're going to do is just a few examples here. We're going to take 14x to the 4th power over 25 times 40 over 7x squared. So the only thing I've done differently from the review problem is I threw some x's in there, so that shouldn't cause you any problems. I'm going to cancel common factors top to bottom. Is there anything in 14 that is living on the bottom? And you should spot that you can cancel a 7 out of these. When I divide by 7, I get a 2. Down here, I get a 1. Are there any x's living on the bottom? And the answer is yes, there's 2 of them. So I'm going to divide 2 out of here, leaving no x's. I'm going to divide this one by 2 x's, leaving me with x squared. 40 has a 4 in it, that doesn't live in 25, has a 10 in it, doesn't live in here, has an 8 in it, has a 5 in it, there it is. So I'm going to divide a 5 out of the 40. I'm going to divide a 5 out of the 25. When I think, it kind of looks like a mess because I slash at everything, but when I think I've got all my common factors canceled from top to bottom, then I multiply straight across. 2 times x squared times 8 gives me a 16 x squared living on the top. On the bottom, I've got 5 times 1, which gives me just a 5. I know I canceled everything possible because 16 over 5 doesn't reduce. Had I gotten like 16 over 12 though, I would know that I didn't cancel enough and I would just continue going. So if you don't find every hidden factor, just make sure you cancel completely at the end. So those kind of fairly straightforward. What generally causes problems is when we start introducing things that need to get factored first. So let's write this one down. And I'm not going to do very many examples. I am just going to make sure I do them really slow. So go ahead and write that down. And let's discuss first of all what we can do and what we can't do. I can cancel this 5 with this 15, leaving a 3, because they are not living next to pluses or minuses, so it's perfectly legal for me to cancel those. But I cannot cancel like this x with a couple of these, because those aren't factors, they're parts of addition and subtraction, so we cannot do that. What we have to do first, this is really important, and it's what I'm going to ask you when you come up to discuss your notes with me, is before you really even start canceling anything, even if you can, you are going to take and factor everything possible first. And you have to remember your factoring. If there's something like this, then we note that they're both even, and we factor out a 2. Go ahead and write that down. If it's something like this, we have to recognize that this is the kind that we unfoil. X, X, and 5 times 2 equals 10, while adding up to 7. So we have to remember how to factor. Once we've factored, then and only then can you cancel. So let's go back to this problem. On the top, I have a 1 because I canceled it with the 15 down there on the bottom. This right here needs to get factored. Does anything go into all those terms? And the answer is no. So I try to break it up. It would have to lead an x and x. What multiplies to equal 18 that I can get a 9 out of? And we've done so many of these, hopefully you just immediately go right to 3 and 6. However, that's a minus 9, so I'm going to make sure I do minus, minus. On the top over here, can I take anything out? And the answer is yes. That's always the first question you ask yourself. Can I take anything out? On the bottom, I have that 3 left over from dividing a 5 out of it. Now I can cancel any common factors. I have a whole factor of x minus 6 on the bottom and on the top. Once I'm done, I multiply straight across. Let's just write mult here. So 1 times 5 on the top is a 5. On the bottom, I have an x minus 3 times 3, and we usually will write that out front. You don't need to distribute that in. You can just go ahead and leave it just like that. So really, I'm only going to do one more. I'm just going to do it nice and slow. If your worksheet is not going well, what I'll do is send you back to look at these notes, because I'm going really slow and explaining it in really great detail. So last example, number 3, let's write it down. 6x plus 18 over x squared minus 9 times 4x minus 12 over 4x. You might be tempted to cancel those 4x's off, but you can't because the one of them is living next to this minus. So we need to remember our number one goal. I can't cancel the 4's off. I can't cancel this 18 with this 9. I need to make sure, number one, that I factor first. So let's begin that. And our first question we ask ourselves is, can I pull anything out of this? For sure, because they're both even, I could pull out a 2, but obviously I got a nice big 6 that can be divided out of both of those. So I divide a 6 out of the top. Then I go to the bottom and I say, can I pull anything out of that? And the answer is no, but we did a whole worksheet on these in our factor unit. They're called differences of squares. So when the answer is no, we try to unfoil. X times x gives me x squared, and 3 times 3 gives me the 9. However, to create that minus 9, I need 1 plus and 1 minus. On the top of the next fraction, I've got a 4 hiding in both terms, so I factor a 4 out of both. And the bottom remains 4 times x. Now I just go cancel any common factors. I can see a 4 staring me in the face right here. I can see an x plus 3 right in my face, and I can see an x minus 3. The only thing left here when I'm all done is a 6 living on the top and an x living on the bottom. And I know that that's as good as it gets because that doesn't reduce. So right now, the worksheet that you're going to go grab is worksheet number 5. It's purple. Whoops, I forgot to write the 5 there. Worksheet number 5, it's purple. So make sure that's the next one you grab. I would like you to do the first 2 and have somebody check it before you move on because this one tends to be a little trickier. All right, have a good one.